Now let's take a look at number 2 from the Chapter 5 AP packet. Let f be a twice differentiable function defined on the interval with f of 1 equals 3. So that's a point they give me. I would box it, highlight it, whatever I need to do to identify that this is given to me. They don't give values randomly. They're given for an intent to be used somewhere. Also, I read this and I see the graph of f prime is shown. So I'm going to write that again so I understand that this is f prime, not f. So I only have one point on the graph of f, but I have an entire graph of f prime. F prime crosses the x-axis at -1 and 3 and has a horizontal tangent at x equals 2. So that means here it would have a horizontal tangent. Let g be the function defined by g of x equals e to the power of f of x. Part A, write an equation for a line tangent to the graph of g at x equals 1. What are the two things we need for the equation of a line? A point and a slope. So I need g of 1 and I need g prime of 1. I need to be able to show I'm going to get these somehow. So g of 1 is pretty easy. E of f of 1, which f of 1 was given in the directions to be 3. So then this is e cubed. Now g prime of 1 will only be found if I find the derivative. So I need to find the derivative. G prime of x equals the derivative of e to the power of f of x is e to the power of f of x times f prime of x. That's your chain rule. G prime of 1 equals e to the power of f of 1 times f prime of 1. E to the power of f of 1 is, again, e cubed. And an f prime of 1, I'm looking at the graph and I'm looking at this point right here. F prime, because this is the graph of f prime, at 1 is -4. So then g prime of 1 is -4 e cubed. With a point and a slope, I can write an equation of a line. Y minus e cubed equals your slope, which is the derivative, -4 e cubed, and then x minus 1. Now, for part B, find all values of x for which g has a local maximum. Let's think about that justification first. How does g have a local maximum? G has a local max at some point, since it must be true that if g has a local max, g prime changes from positive to negative. So let's find when that happens. When does g prime change from positive to negative? So I want the derivative g prime of x, which earlier I found out is e to the power of f of x times f prime of x. And what I'm going to do is I'm going to set this equal to 0. If I want to figure out where g prime goes from positive to negative, I need to figure out where it crosses 0. E to the power of f of x never equals 0. F prime of x is 0. Since this is the graph of f prime of x, f prime of x is 0 at -1 and 3. So at x equals -1, x equals 3. So then, since in fact e to the power of f of x is always positive, all I have to look at is f prime of x. When does f prime of x change from positive to negative? And I see that is true at -1. So then all I have to do is fill in -1 right there, and I'm done. The second derivative is given to you. Is g double prime of -1 positive, negative, or 0? Justify your answer. If I'm trying to figure out if g double prime of -1 is positive, negative, or 0, I want to find each component separately. and then figure out what does all that together give me. Right away, as I'm looking at this, I know e to the power of f of x will always be positive. What about f prime of x squared? F prime of x, well, I don't know anything about f prime of x because it changes, but I do know that f prime of -1 quantity squared will be, the only way I'm going to figure this out if I look at the graph. So let's go to f prime of -1. F prime of -1, oh, that's 0. So then I have a positive number here, and I have 0 here, brackets. So then what is true about f double prime of x? Well, there can be a lot of things happening. But f double prime of -1, if I look at it carefully, that would be if the slope at this point. The reason it's a slope is because this is already the graph of f prime. F prime is decreasing at -1. If f prime is decreasing, f double prime is negative. So if I look at this all together, I have a positive times 0 plus a negative is a negative. Positive times negative is negative. So that's all I need to look for. This would be your justification right here, showing how you found each individual component. So g double prime of -1 is less than 0. Answer the question, and then your justification, like I said, is identifying what's the value of each element, positive, negative, or 0. Last, find the average rate of change of g prime, the derivative of g, over the interval. The average rate of change, but of g prime. So I'm looking for g prime of 3 minus g prime of 1 over 3 minus 1. The reason I need the derivative is because I'm looking for the average rate of change of this function, g prime. Let's find out what g prime of 3 is. Earlier, I found g prime of x right there, so I can plug in e of f of 3 times f prime of 3. F of 3 is not given anywhere for me. Maybe it's not needed. F prime of 3. I look at the graph, and I figure out what is f prime of 3. I can see f prime at 3 is 0. So this whole thing equals 0. G prime of 1 I found at the very, very beginning, which was -4, it's right here, e cubed. -4 e cubed. I fill this all in, 0 minus -4 e cubed divided by 2. If I clean it up, I get 2 e cubed. That's it.